Alright, let's continue on with the Chapter 2 review, and let's look at problem number 14 through 18 in this little video. And went ahead and put the answers up here so that we can just go ahead and start talking about them. Number 14, hopefully you're getting fairly competent in looking at these graphs, and I think it's a good idea to go ahead and, on all these types of problems, is to go ahead and write what's being graphed, even though they tell you it's the function. So we're looking for the following intervals to see when it's increasing and decreasing. When does the derivative, is it positive? When's the slope positive, negative, etc. So the first part says, when is the intervals of this function, when is its derivative negative and when is it positive? So if you have a highlighter, maybe it's a good idea to go ahead and highlight some of this information. But I always want to start and look at the spots where the derivative is equal to 0. So it's equal to 0, and maybe we can just write it out here. You might want to write dy dx is equal to the slope, which is equal to 0 at x equals, looks like negative 1, 2, 3, 4, 5. So at x equals negative 5. And also there's another local minimum, so the derivative is equal to 0 at x equals 0. And finally, it looks like it does it one more time with the local maximum at 1, 2, 3, 4. Right about in there. So these are sort of our dividing lines when things are positive and negative. Okay, so I'll use a yellow highlighter and we'll use that to answer part A. So the slope of the tangent lines between negative 5 and 0 is certainly negative there. The function is decreasing. And then again, over in this region, all the way down to infinity, from 4 to infinity. So notice how the notation is written right here. This interval notation, negative 5 to 0, not inclusive of 0, but approaching 0. That's one way of looking at it. And also from 4 to infinity. Now, it's not listed in the answer choices like this, but you could also write it in inequality sense by writing them like this. Either answer would be acceptable. Alright, so using another highlighter, I'll just highlight it in green when it's positive. Well, it's going to be positive everywhere else. We've already identified where it's 0, where it's negative, and now it's where it's positive. So hopefully this interval notation is not so scary to you anymore. Alright, in 15 through 18, they want you to determine the points at which you cannot take the derivative. Well, of course, along this portion of the curve, you could take the derivative all the way up until that point of discontinuity at x equals 6. And likewise, you could take the derivative starting as you approach it from the right-hand side of 6. You could take the derivative anywhere along there, but not at 6 because of that jump discontinuity. And problem 16 is very similar with one little twist in there. At x equals 5, there's a pretty pronounced vertical tangent line. So you can't take the derivative at that tangent line. And then, of course, you have a vertical asymptote there at x equals negative 6. So discontinuity certainly exists. So just remember that at x equals 5, this function is continuous at x equals 5, but because of that vertical tangent line, it's undefined derivative at that spot. So looking at number 17, let's point out the places where we have trouble. It's continuous all the way until we get to that sharp corner or that cusp. And then once you turn that corner, you can start taking the derivative again, but at x equals, looks like a negative 3, it has a point of at x equals -3. You can't take the derivative, so it's not differentiable at x equals -3 because of a cusp, or sometimes we just call it a corner. Alright, and number 18, let's examine that graph. This is the function here, and this looks like it's pretty smooth all the way along, and not quite a vertical tangent here, but this one looks like it's continuous everywhere, so you could just put that it's differentiable for every x in f of x. So anyway, we'll make one more video to wrap up this chapter review,